Good morning or afternoon, whenever you're listening to this, Year 11. What I want to do today is just have a look over at HSC style questions on all of the formulas we've been doing. So we've done, I just counted, it was, 13 formulas, and then more if you count the positive and the negative version. So there's a lot of formulas there. Become familiar with what is on your reference sheet and what isn't on your reference sheet. That's important. But let's just have a go together at a bunch of HSC style questions, and then the rest of the lesson you can use to finish off any of those exercises in 1103. So this is the first one, straight out of 2016's HSC. So if you want to pause the video, give it a go, and then come back, you can do that now. Okay, I'm going to assume you've given it a go. The first thing I do is especially when I'm learning, I have all the formulas written out on a sheet next to me. And in fact, I will scan through a copy of the exact sheet I've written up with all those important formulas for you and attach to the link on Compass. But I have them all in front of me while I'm still getting my head around them. Eventually, you want to try and do it with only your reference sheet. But I'm looking at what this looks familiar as. And here's my formula, my sum and difference of tan. So looking at this straight away, I can say to myself, well, I know that A is equal to, by looking at this, 2x, and B is equal to x. Okay, so just looking at the placement of the letters. So therefore, that must mean that tan is A minus B, which gives me 2x minus x. Which 2x minus x just gives me 1x, which gives you your answer there. So that one, not a bad multiple choice question, really. All right, let's go to the next one. Okay, here's the next question. If you want to copy it down, I will also post this entire document onto Compass as well, so you do have all of this if you want to just jump into the question rather than copy it down. All right, pause now, give it a go, see how you go. All right, assuming you've given that a go, the first thing I thought was, okay, well, if I need to know the value of sine 2x, I'm going to write that formula out for what I know sine 2x is, the double angle formula. So now I say, okay, well, what do I know with this formula? I know sine of x is 1/4, they gave me that, but what I'm missing is cos of x. So if I know what sine of something is and I need to know what cos of something is, draw a triangle. We'll call this our x, or our angle that we want to find. Opposite hypotenuse gives me 1/4. So now, using Pythagoras, this is going to be 4 squared minus 1 squared, which is going to give me root 15. I'm going to leave it as a third. So now, I say, okay, well now I know everything I need to sub in. So sine of 2x is going to be 2 sine of x, which they gave me, is 1/4. Timesing by cos of x, which now if I look at this angle and I need to do cos, it's adjacent over hypotenuse, which is going to be my root 15 on 4. Clean that all up, what do I get? 2 root 15 on 16, which is the same thing as root 15 on 8 when I simplify. Now, there's still one more part. It's about whether it's a positive or a negative answer. To think about that, all I have to do is think, well, that's where I take into the consideration the domain they've given me. Let's think about, well, over this domain, I need to think about what cos of this angle is going to be, whether it's positive or negative. They told me that all of these angles, x, whatever x is, we don't know. I mean, we could find it, but without finding it, whatever x is, it's between pi on 2 and pi. So if I simply just think about the cos graph, which I know looks like this, I have pi here, I have a bit out of scale, but pi on 2. All my values that this question is looking at are in here, between those two. And you can see that in between, in that domain, pi is always negative. Cos is always negative, okay? Which tells you that when you take cos of this angle, no matter what angle it is, if it's got to be in between those two domains, it's going to give you a negative answer, okay? Which will give you negative and a negative. So then you get an answer of B. Okay. So the domain then gives it away. That domain's saying check your answer for positive or negative. Okay. All right, here's the next one. Copy it down, pause the video, give it a go. Okay, assuming you've given it a go. First thing I would do is go, oh, I remember when Miss said if we have tan of an angle and we don't have that angle in our triangle, or when we try and do ASTC, we still don't get the angle in the triangle, we try and split that up, okay? We need to split it up into either 45, 30, or 60 because there are triangle angles. So it's a matter of finding combination, and then it becomes quite obvious that it's going to be 45 plus 30. Now, it doesn't obviously matter if you do 30 plus 45 or vice versa. So now it's just a matter of, well, plug it into the formula, work out what tan 45 and tan 30 is from your triangles, and then simplify it all the way down to A and B. So let's see. So plugging the values into the formula, this is what I get. So now I've just used my triangles. I've found the exact ratios. I didn't put it as a fraction because I started noticing I'm getting a fraction dividing by a fraction, so I prefer to write the divide sign rather than the fraction. Let's see when I clean it up. Okay, I'm just going to show you what I've done here in a bit more detail. So I've assumed here, just to clean it up, because I don't want to use a calculator, we need to find A and B as whole numbers. Remember, number 1, that's the same thing as root 3 on root 3. So I've just counted as that, so then it becomes root 3 plus 1 on root 3. And then same thing here, number 1, root 3 on root 3, just to give me the same denominators. So then I get the next line here. Dividing, then that tells me that I flip and time, so I end up with this. Like that. And what do I see? I can cancel here. I can't cancel the root 3 on here with the root 3 or the 1 and the minus 1 because they're two terms. I'd have to cancel something from both of those two terms and both of those two terms. Where root 3 and root 3, they're separate terms. So what I end up with is root 3 plus 1 on root 3 minus 1. But it's still not quite looking like the answer I need. Look at the answer you need. Notice how it's rational. We have it's got a rational denominator, I should say. Okay, there's no cert on the denominator, but we have one. So what I need to do is rationalize the denominator. So remember, rationalizing denominator, we times the top and the bottom by the conjugate of the denominator. So root 3 plus 1 and root 3 plus 1. When I do that, if I expand it out using FOIL, now you'll get a rational denominator, okay? So root 3 times root 3 just gives me 3. Then I'll get 2 root 3 plus 1 on top, all over. Now, the bottom's always a difference of 2 squares when you rationalize the denominator. So square the first gives me 3 minus square the last, which gives me, what do I get? 4 plus 2 root 3 on 2. And then now I can simplify it because I can divide every term by 2, which will give me 2 plus 1 root 3, which is just root 3, all on 1, which is just the same thing as that. So now I can come back up here and go, all right, well, A is 2 and B is 1. So therefore A equals 2 and B equals 1. So there's a fair bit to do to get to that answer. But it's not overly complicated. Okay, I'm going to leave it there for that. I just wanted to show you a couple of HSC style questions on what you could expect. And a lot of these are often used in harder trig that we do down the track more, like we integrate with some of these formulas and things. So for now, that's the extent of it. I mean, they can ask you in trickier ways, I guess, but that's what you'd expect at this point in time, okay? So I'm going to upload the rest of the document on Smarter Maths, which has a couple more questions in here. Some I've just done with you, others I haven't. The ones I haven't, I want you to give a go now for the rest of the class time. The work solutions are all attached. And then once you finish the ones we haven't done together just now, from this, then you can go and finish off those questions from last lesson on exercise 1103. So email me if you have any questions.